Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody, and this is going to be an interesting show. Now, I have to apologize just a little bit. The past few shows I've been drawn into this quagmire of baloney that's been on the internet, and I got to get back to science, hardcore science on this show. That's what it's all about. And of course, I do have to rout out the misconceptions, but what I'm doing is I'm posting on both my YouTube channel and my Patreon channel I call it the baloney topics, like is this comet a space alien craft, did NASA discover life on Mars, all of this baloney that's coming at you. I'm putting on separate postings on my YouTube and Patreon channel, so go there for those announcements and that information, and it's pretty detailed. And I don't just talk about that. I go on and I talk about the real situation. What is the real situation about life on Mars? There is a real story, but you're not getting it from any place in the mainstream science media. And then also like I say, the issue about is this comet a alien spacecraft. I mean, all the craziness going on. But there's a real story behind that. And so anyway, go to those other postings that they're called posts. And so you will see them on the YouTube and Patreon channels. Okay, but tonight's main topic, I'm going to talk about the physics of green comets. Now, this brings in a lot of extra topics, a lot of topics that of physics, a lot of information about how comets work, about plasma physics. And by the way, these lectures are for the general public, and I know there's a lot of professionals listening in, also sitting in there. They don't do it in front of their colleagues, but I know that they're there. Hello out there, all you physicists and NASA scientists who are listening in to get the real story, because you're in your little cubicle out there in NASA land in JPL Goddard or Los Alamos or wherever you are, wherever you get your paycheck from, so you can't say anything. I know you're listening, lots of you, lots and lots, so welcome, you're welcome too. Okay, the physics of green comets. Now, green comets, it sounds like little green men. No, they are real. And what I find strange is that recently, with the comet 3I Atlas is turned green. And so they're saying, oh, these are rare, like every 50,000 years you might see one. And that's really not true. It turns out that all comets have a green halo. It's just that it's more visible in some than others. And it depends on quite a few factors. But where does this green color come from? And I'll read some notes here from some recent articles about their speculation of where it comes from in this comet 3I Atlas, which is just, and literally every comet has a green halo, let me tell you. It's part of the structure of the comet. But if you think comets are dirty snowballs that sublimate in the solar wind, then there is no explanation. There is no explanation. Why is this bulbous cloud, perfect sphere around the nucleus going out sometimes 100,000 miles, 20,000 miles on a small comet, 100,000 miles on a medium comet, and up to 1,000,000 miles like Comet Holmes? had a complete spherical shell around it that was, now this is, mind you, Comet Holmes at the time this happened, was beyond the orbit of Mars. It was between Mars and Jupiter, and it not physically, but visually was as large as the full moon. I remember going out and seeing it in the evening sky. It was, it was still light out, and I could see Comet Holmes up in the sky with no equipment, just looking at it, size of the full moon. And that's something, by the way, I predicted. And it was a green comet. That was a green halo. So where is this coming from? What is the story on this? So, okay, first of all, let's go through a little solar physics. And I have this chart behind me is really handy because, in fact, this figure right here is one I will be using. And remember, that was drawn for a paper that I submitted to, this was for a poster session I did at an American Geophysical Union meeting in 1986. Yes, 86 was when that drawing was made, and it is still as relevant today as always. But it shows the analysis of the ISW-3 satellite going through the back end of the tail side, that is, of Comet Giacobini-Zinner, which was the first comet to ever be visited by a man-made spacecraft. And I've talked about this on previous shows. But in Giacobini-Zinner was a green comet, had green halo around it. So what's going on here? What is the cause of this? What's the physics of a green comet? And by the way, you'll see the green, the tinges of green, you'll see it also in the tail. And you'll see the somewhat of a halo around the tail region that is green. And it's really not green, it's kind of a blue-green, and I'll show you where it comes from. It's the only species of a chemical species that could possibly have enough abundance out there to cause this. But there's a twist to it. There's a very interesting twist. We'll be talking about the spectral lines of hydrogen, atomic hydrogen, and we'll go into detail on how that works, like when you have a laboratory tube, and deuterium, one of its close relatives. So the deuterium atom is a hydrogen atom with a neutron, and so it skews the Balmer line, which is the visible set of lines for the hydrogen atom. It skews them just a little bit to the higher energy range. It kind of, you might say, blue shifts them. It pushes them up to a shorter wavelength, higher frequency photon. And so anyway, we're not sure, because here's the other part of this strange story. NASA is hiding the data. Yes, NASA, illustrious NASA, never a straight answer, hiding the data on Comet 3I Atlas. And why are they doing that? Because they don't know what it means. And so they come out and they make this public statement that it's not a spacecraft, but they won't release the spectrum because it has too many things that the spaceship advocate people would jump all over. But see, NASA can't explain it because they don't have me in their ranks. But we'll explain it tonight. So, to understand the physics of the green comet, we have to understand the physics of a comet. What is a comet, really? It's the discharge of the solar capacitor. Okay, that's an easy statement. And right above me here, this is, of course, my signature work that includes so many other things. For example, the tornadoes on the sun, or the fact that fusion on the sun is not at the core, it's in the upper atmosphere. And part of that fusion process is the separation of charge, which gives us the solar corona, the sea of relativistic electrons surrounding the positively charged inner sun, in other words, the solar surface, And the corona is that sea of electrons. You can actually see it giving off visible light that orbits the sun, and you can see that during a solar eclipse. You can see the corona, and then the solar corona is like a mesh. It's like in a laboratory you would have a screen, and say at a high voltage, a high negative voltage, and you have protons coming off the sun and are accelerated towards this. And what happens is, because of the protons are bundled, they come out and they actually blow a magnetic hole through the corona, and they are accelerated and ejected at high velocity from the sun, and that's the source of the solar wind. So the majority, not the majority, but it's a very subtle concept that there's an excess current of protons in a solar wind. Now you have to understand what current is in physics. It's the charge times velocity. Charge times velocity. So you have to include both those factors to understand that when I say there's an excess current of protons in the solar wind, I say current. I don't say an excess charge. I say an excess current. Very different meaning. And that's why I'll tell you, trained plasma physicists have a hard time with it, because they are so far in the cave ages relative to physics and solar physics, and they're talking about magnetic reconnection. Most plasma physicists think that magnetic fields just exist in outer space like magic. They just appear. They don't have any source. They don't have any backbone, so to speak. But anyway, the discharge of the solar capacitor is built up because of the excess current of protons in the solar wind, which sweeps out dust and gases, leaving the fine stuff, the little stuff, in the inner solar system. And it's kind of like a centrifuge. It's kind of like a physical centrifuge, and it blows the dust and gases out to a spot far out, a nebular ion cloud that is far beyond the orbit of Pluto. And when I started talking about this in 1979, everybody thought, and when I was at Cornell, everybody thought that the solar wind ended around the orbit of Jupiter. Nobody had a clue. Of course, then the Voyager spacecraft went out, and the solar wind kept going and going, like the Ever-Ready Bunny, just never stopped. And of course, now we know that one of the Voyager spacecraft crossed the heliopause, entered intergalactic space, and found it to be very chaotic. But at any rate, that's another story for another day. So now let's take a look at this discharge. The comet nucleus is just a rock. It's not an ice ball. In fact, it's pretty hot. It's far too hot to have liquid water on the surface. But if the objects are large enough, for example, like Hale-Bopp, which was planetary size, then they have enough gravitational pull to keep the material there that is drawn in through electrical forces. So basically, a comet works in the following way. It discharges the solar capacitor. The bulk charge carrier in that discharge is in the form of electrons coming out from the sunward side. Okay, and why is that? That's charge to mass ratio. Very simple. Very simple. Charge to mass ratio. Electrons a couple thousand times more than protons. Tens of thousand times more than atoms and ions. Millions of times more than dust particles. And so the bulk charge carrier in that discharge is electrons. It's a pinched electron beam coming out from the sun, exactly where the nucleus is. And why does that work? Because it's like the backyard bug killer, a very good example that everybody is aware of, that when the bug flies in between the grid plates of the backyard bug killer, guess what? That's where the discharge goes. That's where it always goes, always, 100% of the time. And it stays there, and if the bug were able to fly around in there, the discharge would follow him exactly where the bug is. Because that's like it's like a finger sticking in and bringing in that outside potential. Okay, so the comet nucleus then is like a rock in a stream the electron beam hits it, it builds up a back pressure, and that creates an accumulation of charge around the comet nucleus. Space charge sheath. The comet nucleus is not negatively charged, but this beam is coming in and many times hits it and bakes on, for example, a lot of the comet nuclei that we've seen have either the 67P lander, was the Philae lander, saw organic compounds on the surface of that nucleus. No water, no ice, no snow, nothing coming off the nucleus. I talked to the lead scientists at the European Space Agency, the Rosetta mission, and I said, what's the closest you detected water from that comet nucleus, 67P? They said 10 kilometers. That was the closest point at which they detected water molecules. There was nothing coming off the nucleus at all, yet it had a water tail. Okay, so anyway, what happens is there's a space charge that builds up around the comet nucleus, and then that electron beam flows around the comet nucleus and continues out here. So that's what this picture is depicting. And now you see these lines here. These are the field lines. It's a combination electric field of the sun, the negatively charged sun, and the comet nucleus. And so that's where the shape of the comet comes from. So the water molecules are forming the oxygen, the hydrogen are coming in, and as they join, they give off heat. And but anyway, they come in much slower than the charge accumulation at the nucleus, and that keeps this process going. So the end story is that the comet nucleus has a space charge sheath around it that is negative, right there, right at the nucleus. And the Giotto spacecraft flew right through it, flew through the nose side of the Comet Halley, and it threw it way off course, exactly as I predicted, and the electron counts went off scale. So it flew right through the nose side of that comet and detected all of the electromagnetic, the magnetometers went off scale, everything went off scale. It took them about a couple days to regain control of that spacecraft, gyro-stabilized spacecraft at Comet Halley, the Giotto spacecraft from France. Okay, so anyway, now what we have is a negative space charge around the comet nucleus, and this is the key to understanding the green halo around the comet nucleus. The space charge in outer space does not last long. So what do you have available there in great quantity? You have atomic hydrogen. Now here is I'm going to show you some photographs here, and also the spectrum of hydrogen and deuterium. And we're going to show how these are related to the color of the green comet. For more information on this topic and a lot more topics, visit my Patreon channel, JMCCSCI. So that's patreon.com/JMCCSCI. By the way, if you are a member of my Patreon channel, you can watch the live show also there and watch the continuation of the entire show in one sitting, or you can watch the archives at any time afterwards. So there's a lot of benefits to being a member of the Patreon channel. Talk to you soon.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before.